So here again we're asked where is the function continuous, and in this particular question we are given a fraction, and anytime we're given a fraction we know that our function will be continuous provided that the denominator is not equal to 0. So this will be continuous if the denominator is not equal to 0. So we'll start by setting the denominator equal to 0 and try to find the points that we do not have in our domain. Now, this is a polynomial expression because we have a highest power of 2. So the first thing that we would try to do is factor out the GCF. So in this case, you look, the GCF, remember, is the smallest exponent that is on both of those variables. So we have x squared, x to the first, so our GCF will be equal to x. So as a polynomial equation, we will solve by factoring first out an x, and that will leave us with x times x minus 1 equal to 0. Now, at this point, it is factored, so we can set the x equal to 0, that factor equal to 0, and the x minus 1 equal to 0. Solving, we get x is equal to 1, and x is equal to 0. Now, keep in mind that those are the numbers that we cannot, because if we have those two numbers, they will cause the function to have a 0 in the denominator and therefore not be in the domain. So our conclusion here is that this function is continuous if x is not equal to 0 and x is not equal to 1. Okay, so what we did is we set the denominator equal to 0. This is a polynomial equation. Highest power is 2. We see there's a GCF. We factor out that GCF and then set the factors equal to 0. Now, when they ask us what type of discontinuity we have, remember that's where we have to go over here and ask ourselves if the denominator cancels. Because if the denominator cancels, we have a removable discontinuity. If it does not, then we have a non-removable or infinite discontinuity because we're really looking at a vertical asymptote. So what we will do here is we will go back to the function and we will say, okay, does the denominator cancel? Now, in order to answer that question, we need to factor it. So we need to factor out the x and be left with x minus 1. All right, so now we notice that these x's cancel. So the denominator that cancels is going to give us a whole or a removable discontinuity in the graph. So we set that denominator factor equal to 0, and we conclude that there is a whole at x is equal to 0, which is a removable discontinuity. Okay, so it is removable at x is equal to 0. Now, what is left over is this x minus 1. And that x minus 1, the leftover denominator, that is going to be set equal to 0, and that we could not remove. So it is a non-removable discontinuity. So we have at x is equal to 1 a non-removable. And remember, that really means that we have a vertical asymptote, and so sometimes they'll refer to it as a non-removable discontinuity, or they will simply refer to it as an infinite discontinuity. And I really want you to know both. I want you to know that non-removable is the same as an infinite discontinuity, and that occurs at x is equal to 1.